So today we're going to be looking at independent events or independent different sets, what we're going to look at. So one thing we're going to discuss is what are independent events. Well, independent events are when the occurrence of one event does not affect the occurrence of another event. So when the occurrence of one event does not affect the occurrence of another event. So an example I want to give is a jar that contains 15 marbles and 17 yellow marbles. And you want to find the probability of this. We're going to figure that out in a minute. But an event that doesn't influence the other one. So a good example of an independent event would be flipping a coin. Because no matter what you got for the first time you flip the coin, you're still going to have the same number of chances. Another key phrase to go along with independent events are replace or to put back. So if it says you replace something or you put it back, that means it's going to be an independent event because it does not, the first choice does not affect the overall thing for the second event. So let's look at our example of our 15 red marbles and 17 yellow marbles. So first we're going to take, let's let R be red marble. And let Y be yellow. So R is the red marble, Y is the yellow marble. So suppose you draw the red marble and put it back into the jar before you draw the second marble. So you draw a red marble and put it back. Here's our key phrase. We put it back, meaning this will be an independent event. And the jar, then we draw a second marble. We want to find the probability that the second marble that we draw is yellow, given the first one we drew was red. Well, right here, we know we put it back. So let's first look at how many total marbles we have in the jar. Well, we have 15 red marbles and 17 yellow. 15 plus 17 is, there's a total of 32 marbles. We took out one red marble, then we put it back. So there's still exactly 32 marbles in our jar. We know this because we put the marble back. So to find the probability of this one, we're going to take the number of yellow marbles and put it over the total number of marbles, again, because we still have 32 marbles. So the probability of drawing a yellow, given the first one was red, is still going to be 17 over 32 because we put the red marble back into the jar, so it's still the same number. Well, what if I suppose that I did not put the back? You did not put the marble back. Put the red marble back. We want to find the probability of the second marble being yellow, given that you did not put the red marble back. Well, now we have one less marble. We have one less red marble. We still have the same number of yellow marbles, but we have one less red marble. So that means there's only 14 red marbles inside our jar. So there's going to be a total of 31 marbles in the jar, but there's still 17 red, or yellow. There's still 17 yellow, there's 14 red. So for this one, the probability, again, is going to be the same as before. We take the total number of marbles and set this number over top of the total. So we're going to set up a 17 over 31. Now this one changes. This is not independent. because our probability changed because we didn't put the marble back. So this is a dependent event, while this one's independent. Keep that in mind. Because it changed our outcome, it is going to be a dependent event, not an independent event. And we'll go more detailed on that tomorrow. Now let's find the probability of independent events, and then we're going to go to our spinner in a minute. Finding the probability of independent events, not like the last one we just had. Finding the probability of independent events follows one specific formula. The probability of A union B is going to be the probability of A multiplied by the probability of B. Again, A and B are just different events. We're going to show you this on the next example that we're going to look at. Actually, let's use it with the same marbles that we had before. So again, we had 17 yellow, 15 red marbles, and 32 total marbles. We want to find the probability for drawing a red marble, replacing it, and drawing a yellow marble. So the first thing we need to do is look at the probability of drawing a red marble. Well, we know there's 15 red marbles, so let's start with the probability of red. Well, we know there's 15 red over a total of 32. So that is the probability of drawing a red marble. Now remember, when we take out our red marble, we put it back. So let's look at the probability of a yellow marble. Again, we still have 32 marbles in the jar because we replaced it. So we have 17 yellow marbles, again, over 32. So if we were to draw a red marble first, replace it, and then draw a yellow marble, we would set it up as the probability of red multiplied by the probability of yellow. So I'm going to set this up. Well, I got it backwards, but it's fine. So the probability of red is, again, 15 over 32. And we're going to multiply that by 17 over 32. If we multiply these together, 15 times 17 is going to be 255. And 32 times 32 is 1,024. That's going to be about 25%. So to find our percent, we're going to take our calculator. We're going to do 255 divided by 1,024 and multiply that by 100. It's about 25%. For these big ones, you can change it to a decimal, you can change it to a percent, or you can leave it as a fraction. I will accept all three. Now let's do one more example of using this multiplication process for the independent events. Let's look at the spinner. So you spin a spinner 2 times. Well, our spinner is always going to be an independent event because no matter what you do the first time, you're not going to take out a chunk of your spinner. You're going to keep it for this one. So your spinner, you spin the spinner 2 times, find the probability that the spinner lands on an even number, and then followed by an odd number. So for this one, we're going to find the probability of even, then odd. So let's look. We have 8 total for our spinner. 8 total numbers. And 1, 2, 3 of them are even. 5 of them are odd. Let's look at the probability of having an even number. Well, the probability of having an even number, well, we have 3 even numbers over 8 total. The probability of an odd number, well, we have 5 odd numbers over 8 total. The probability of even, then drawing an odd, is the same as the probability of even times the probability of odd. Oops, almost put, that's fine. Odd. So we're going to take our two fractions, 3 over 8, and multiply it by 5 over 8. Well, 3 times 5 is 15. 8 times 8 is 64. If we divide that out, it should give us about 23%. Again, we're going to use our calculator. 15 divided by 64. Multiply that by 100. 23%. About 23%. Now I want you guys to do workbook page 61 and 62 and textbook page 958 through 960, numbers 1 through 14.